So the learning objective for this part will be very beginning of atomic theory. We'll talk about what an atom looks like. What are the subatomic particles and what do they look like inside of atom? So we'll talk about model of the atom. We'll go through the ancient time atomic theory from the modern theory and what a real model of atom looks like. And later, we'll talk about different subatomic particles, protons, electrons, and neutrons. Do they sound familiar? Heard those terms before, right? Okay, then from there on, we'll talk about, I think there is a main part over here that related to electrons could be a bit complicated, and that's the atomic spectrum, using atomic spectrum to figure out the electron configurations, electronic structures. And I plan to finish this part in 3 weeks, but if we're doing things perfectly fine, we can move forward so I can add more stuff into the class. All right, let's start from the basic atom. What is atom? Atom is the smallest quality of a matter that, I think this sentence is quite important, still remain the property of the matter. For example, if I have a piece of gold, right? If I have a piece of gold, gold is soft, right? You can keep cut it into smaller and smaller chunks, right? You can cut it in half and you can keep cut it into smaller pieces. Now, ideally, you can cut it into a way that you can no longer split it. What do you mean? What do I mean when I say no longer split it? That means if I continue to split this thing, it will no longer be a gold. It lost its property. Okay, so if we continue split on the atom level, if we continue split, then that's not going to be gold, doesn't exist anymore. So we call the smallest particles that hold the property of gold, it will be considered as a gold atom. And each element have different atoms. So basically, gold have a gold atom. We mark it as gold, but certain compound or certain substrate we see in the lifetime, such as water, right? Do you still remember what's the composition of water? H2O, right? Okay, so when we talk about gold, we're talking about this eventually go to a single element. But if this is a water, of course, we can, cut the water volume into half, keep cutting, keeping the splitting process. Eventually, you're gonna get a molecule that contain an oxygen atom and 2 hydrogen atoms. And that's what H2O means, okay? And H2O, in this case, contain oxygen atom, hydrogen atom, all right? This is what we call a molecule. We'll talk about molecule in Unit 2, but I want to make sure everybody sees the difference between an element and a molecule. A molecule contains more than one type of element with a fixed ratio. All right. In ancient time, I think people are very creative. They are thinking about splitting substrates down, even though they can't really split it into such a tiny level, but they're doing this in their mind. So they bring out a theory. In old time, very old time, the theory says, okay, imagine I have a piece of wood or a piece of anything. We can break it into the smaller things, and every matter around us, every matter in the world, they are composed of tiny particles, and we call those particles atoms. There are not so many type of atoms. If you still remember your periodic table, that's all the elements you have, and that's all different type of atoms you have, okay? You can have carbon atom, and you can have oxygen atom, right? And they can combine to give you molecules such as carbon dioxide, carbon monoxide, but atom-wise, we only have this much amount of atoms, a type of atoms, okay? Then all atoms of a given element, they will have identical chemical properties. Okay, of course, if this is a carbon atom, okay, I want to refer that even though we haven't talked about isotope, but very soon we'll talk about isotope. This is for the ones who heard about isotope. Have you heard about isotope before? Oh, here or there, a little bit, right? For example, carbon actually have the carbon-12 and carbon-13 isotope. But their true identity lays on the number of protons, because carbon-12 have 6 protons, carbon-13 also have 6 protons. That means they belongs to the same element, okay? So even though they don't have the same mass number, but their physical chemical property, I should say chemical property should still remain the same, okay? That's the atom. Atom form chemical compound. They can form compound by combining in the whole number ratio. You can see all type of molecules combine of atoms. This is similar to alphabet. You have 26 letters, but they can combine in a variety of ways that you can have different word, right? So atom can be combined in a variety of different ways that you can get a lot of different compound, such as carbon monoxide, carbon dioxide, right? And later you might see complicated structure contain lots of atom binding together, such as let's do a sugar molecule, something you heard in your life, C6H12O6. So what does this mean? This compound contain how many type of element? It's 3, right?